what we're going to do today is just look at extreme values and trig functions of what we will call extreme values. We're not going to look at values outside of 0 and 2 pi, just because I don't think we have enough time, and we haven't made the test yet, so whatever, we'll just leave it off. Okay? 3 things that we talked about that are important for trig functions at angles. Locating the angle, understand how your triangle is oriented at the side lengths of your triangles, and remembering that sine is always opposite, which always ends up being the vertical distance. Cosine being adjacent, always a horizontal distance. This is the key for today. Remembering that sine is always our vertical distance, and remembering that cosine is always our horizontal distance. Because what we're going to have is a situation where we're talking about pi over 2 pi, 3 pi over 2, 0, where our angles end up being at a location where I can't really draw a triangle. Right? Pi over 2, can you draw a triangle with the x-axis at pi over 2? Not really. Pi, can I draw a triangle with the x-axis at pi? Not really. I'm going to. But it's not going to make much sense. Okay? So I'm just going to throw this down there. Don't freak out. With the triangles that we've been drawing, what has the hypotenuse always been? 1, right? Because it's a unit circle, the hypotenuse is 1. So here's a triangle where the hypotenuse is 1. Now, sine being the vertical side length, what would be the vertical distance here at pi over 2? Like if I did this angle and it was like pi over 6, you'd say the vertical distance is 1/2. It's how much I go up. How much do I go up here? I go up 1. So it's almost like I got a triangle with a hypotenuse of 1 and a vertical distance of 1. How much is my horizontal distance here?
1.
Nope.
0.
It's 0. It's almost like I have a triangle. Hypotenuse 1, vertical distance 1, horizontal distance 0. Right? Kind of confusing this way, which is why we're not really going to do this. Instead, we're going to say, all right, sine's always my vertical distance. Well, at pi over 2, I'm going up 1, but I'm not going left or right at all. Vertical distance, 1, sine of pi over 2, 1. Pi. This triangle is kind of like for this situation. Pi. Well, I'm going to start with a hypotenuse of 1. What's my horizontal distance here? It's 1, but it's not actually 1. I'm going to the left, right? If I drew a 30, 60, 90 here, I'd say, okay, this is up 1/2, but this is over to the left. I'd say that side length is negative. So what do I think I would say this horizontal distance is? -1. What is my vertical distance? 0. It's almost like I have a triangle like this. Now, am I going to use this? No, I don't want this to confuse you, and I don't want you to draw crazy things. Instead, I want you to think cosine, horizontal distance. Horizontally, I'm going to the left 1 because we have a unit circle. Unit circle, radius is 1, right? So I'm going to the left 1. I am not going up or down at all. So my cosine of pi is -1. Okay? What would be the sine of pi then, therefore? Here's pi, horizontal distance. I go to the left 1. That would be the cosine values. Do I go up or down at all to get over here to pi? Nope. So what do you think the sine of pi is? Sine being my vertical distance. 0. The sine of pi ends up being 0. Do we remember what 3 pi over 2 is, where it is? If this is pi, this is 2 pi over 2. Pi over 2 is 90. If I add a pi over 2, I get to 3 pi over 2. 3 pi over 2 is down here. So, down here. Do I travel to the left or to the right to get down here? I just go down 1, right? So I don't go to the left or to the right. Cosine, horizontal distance, x distance. What's the cosine of 3 pi over 2? 0. Okay, to the one that blows everybody's minds. What is the cosine of 0? 1. Very good. How'd you get that, Mr. Manley?
I just figured.
You just figured. No, come on. How do we get that, Ms. Davis? Zero's over here. Okay. Then that line to get there has a horizontal distance of 1, and it's got no vertical distance. So the cosine of 0 is 1. What's the sine of 0? Sine is the vertical distance. The sine of 0 is 0. I do not go up or down at all to get over here to 0. The sine of 0 is 0, but the cosine of 0 is 1. What's the sine of 3 pi over 2? Figure it out. Discuss with your neighbors. Don't shout it out. Okay, discuss with your neighbors now. What is the sine of 3 pi over 2? Nice. Nice. Sine of 3 pi over 2 is -1. Sine, opposite, vertical distance. The vertical distance to get where 3 pi over 2 is, I go down 1, but I do not go to the left or to the right at all. So that's why the sine of 3 pi over 2 is -1. What is the cosine of pi over 2? Discuss with your neighbors. Pi over 2. Up here. Cosine. Adjacent. Adjacent. Horizontal. From the origin, do I go to the left or to the right at all? No. I do go up 1. Cosine of pi over 2 is 0. The sine of pi over 2 is 1. What's the tangent of pi? Tangent is opposite over adjacent. Well, instead of opposite over adjacent, because it's tough with these triangles, because I can't really see them, I'm thinking vertical over horizontal. What's the tangent of pi? Figure it out. Discuss with your neighbors. Where's pi? No, that's 0. Pi's over here. Remember, this is 0 around our circle, 360 degrees, 2 pi, half of that pi. Pi's over here. Vertical, 0. Horizontal, -1. Fortunately, that's 0. But I'd write it as 0 over -1 is -1. What's the tangent of 3 pi over 2? Tangent, opposite over adjacent. Opposite over adjacent. Opposite is always the vertical side distance. Adjacent is always the horizontal side distance. 3 pi over 2. Down, meh. Vertical, -1. Horizontal, 0. I go down 1 from the origin. I do not go to the left or to the right at all. So, undefined. I'm not allowed to divide by 0. Cotangent of 3 pi over 2 would be the adjacent over the opposite, or the horizontal over the vertical. Horizontal, 0. You're allowed to divide 0 by anything. You're not allowed to divide anything by 0. Don't pack up yet. We still have 3 minutes. Let's finish off these 4. What's the cosecant of 3 pi over 2? What? Cosecant is the reciprocal of sine. If you know the sine of 3 pi over 2, you can flip it and get the cosecant of 3 pi over 2. 3 pi over 2. Start with 2 pi over 2, add a pi over 2. Pi over 2s are always 90 degrees. Down here. What's the vertical distance to get down there at the bottom, considering we're on a unit circle? -1. I go down 1. I do not go to the left or to the right at all. So, this is -1. If I take that and flip it, I still get -1. The cosecant of 0. Well, let's find the sine of 0. Here's 0. It's where we start. My vertical distance is 0. My horizontal distance is 1. So, the sine of 0 is 0. If I flip 0, I don't get 0. Flipping 0 gives you 1 over 0. 1 over 0 is undefined. You're not allowed to divide by 0. So that's very important. Some people think that if you flip 0, you get 0. But no, if I flip 0, I'm undefined. Okay, a couple more. Secant of 0. Well, it's the reciprocal of the cosine of 0. At 0, I go to the right 1. I do not go up or down at all. The cosine 0 is 1. Therefore, the secant of 0 is 1. The cosine of pi over 2 is 0. I do not go to the left or to the right at all. I just go up 1. The horizontal distance is 0. Therefore, the cosine of pi over 2 is 0. Therefore, the secant of pi over 2 is undefined. Okay? That's it. That will be on your test on Tuesday. We will have a quiz on it on Friday, if I don't see you.